Hey everyone, so we have an Arrow Lake testing challenge, and this is going to be a really cool video today where this is a super casual video. I have not scripted any of this. Basically, this is almost an older school style where I'm going to show you some of the stuff we're doing in the lab for setup for Arrow Lake. This is an Arrow Lake platform. I wasn't going to show it, but a lot of people are showing their motherboards and their CPUs, so it's not really clear to me what Intel wants from an embargo standpoint. So I have decided that the rules are I can show it as long as the power's not on. I think that makes sense. That's how a bunch of other people did it. So that's Arrow Lake. Anyway, you'll see the reviews soon. Here's the problem though. So we got a tip over a month ago from not Intel, so I can say this freely, and it's also been repeated publicly by other people now. But we got a tip that measuring CPU power at just these two cables, the EPS 12 volt cables, is not sufficient for Arrow Lake. Now, some CPU power comes from places like the 24 pin historically, but if you measure just the EPS 12, you're gonna get so much of the percentage of the power going into the CPU. It stands as a really good metric for just what's the power consumption. You can look at stuff like CPU package power as an example through hardware info. That's an okay read, but those things can be inaccurate, especially for pre-launch hardware. So this has always been a challenge. Another option for measuring CPU power consumption is total system power. The reason this all matters is because Intel made huge claims for the efficiency for Arrow Lake. You're gonna see our testing on that really soon. But because they made such big claims, if it is in fact true that the EPS 12 volt connectors don't show the majority of the power consumption, or even say 90+% of it, and some of it's coming from 24 pin, we now need to measure this too. And so this is the monstrosity that I have constructed. And let me walk you through it, and then we're gonna build another one. Before that, this video is brought to you by Thermaltake and the Tower 600 case. The Tower 600 is a vertical case design with Thermaltake's unique showcase presentation, which stands out further with its separate chassis stand kit that rotates the case for an angled showpiece. The Tower 600 is heavily ventilated around the sides, has a ton of radiator support including up to 420mm solutions, and offers 2 GPU mounting options for display and cooling optimization. It also comes in colors not commonly seen in cases. Learn more about the Tower 600 at the link in the description below. So this thing is called the Bench Lab. This is from Elmor. Elmor makes phenomenal stuff. We use a lot of his stuff here. So this is the Bench Lab. I bought 2 of these quite a while ago without a plan. It was a tech hoarder scenario. I saw it and I was like, I can use that. And then it got here and I was like, I have no idea what to use this for. But now we have a use. So the way this works, this is an interposer board. So this sits between literally the motherboard up here and then a bench platform. And what it does is you wire in all of the power from the power supplies. You see that from PSU. These are all the connectors. And then it spits it all out to the system. And so it's feeding the power from the power supply through the board. Because it's an interposer, it can capture that data and run telemetry. So this is telemetry in the sense of just tracking information, not kind of the internet telemetry idea we have. So end result is I can isolate a bunch of different rails and the cables they come from for measuring power. This is very close. This is like one step removed from total system power. The reason you don't just do total system power if you want to do what we're trying to do, which is isolate for components, is that isolating components part. So let me show you a couple other tools to give kind of some perspective of why this is so interesting. First of all, you could do something like this. This is another, oh, hang on, blur the screen. So this is an Elmor PMD. We've shown these before. We used these like over a year ago, I think, for some content. And I've recommended them to a lot of reviewers, seen them get picked up by a lot of people. So it's cool to see because it's an awesome tool. So this is a smaller interposer. It is a PCB that takes power from the power supply, goes to the system, and in between it reads what those numbers are. Hardware info can read this as well. So then it plugs into the system. So historically, we haven't really shown a lot of the tools we use for a number of reasons, but the stuff we're doing these days, it's like, I messaged Wendell the other day a photo of the system that I just showed you all at the start. And I sent it to him and I said, I love my job, this is awesome. So I wanted to show some of it. So a lot of you are probably familiar with current clamps. These are very standard. You clamp the cables you want to measure the current from, and you can just do it by taking like an extension cable just to split it out really cleanly and obviously, and clamp that would be into the system, clamp the 12 volt or something. So that's another option. If 24 pin really matters, we need to capture it. And so we have this thing, which I got in expedited. This is the PMD2. And just to be clear, we have no affiliation with Elmor. I have spent like over, I don't know, I've spent a lot of money on his store. I love the stuff he makes, it's so good. So this is a PMD2, and this does capture 24 pin, that's what that is. So that connects to the motherboard. Now we can read EPS, 24, we can even take PCIe, 12 volt high power, and it's all the same stuff. And then we feed it through software. We have a bunch of in-house software we've built that we don't share, but we've built a lot of tools to kind of analyze and work with all this stuff and process it. So we started using that. The problem with that, as good as it is this. Now, this is called a video card. So here's the problem. 24 pin also feeds power to the PCIe slots. So if you want to measure, in our case, I guess I should define the objectives here. Remember I said it wasn't scripted? The objectives are measure the CPU power consumption as accurately as possible while isolating to as close to the CPU as possible. And so the reason we don't do software is because for a lot of reasons historically, it may be the case that the way software reads CPU package power or whatever power numbers it may present for Intel versus AMD is not consistent or is opaque. It's not transparent. It's not clear to us what precisely it's doing. So my general rule is don't trust software. Now, it's pretty good sometimes, but especially for pre-launch stuff, we just can't. So that leaves us with hardware. Hardware options are wall power. Come with me if you want to live. I want to be clear, I was not threatening Vitalii. That was a movie reference. So you could, this is very echoey in here, could measure through a different interposer. This is total system power. Feed the power on one side, comes out the other side, and capture it, spit it out to a log. These are super common. A lot of you know what these are. This is a kilowatt. So this is like the least sort of precise, but great spot checking tool. Not useful for us in a lab environment because you look at it, you write down the number, and there's just a lot of imprecision there. It can kind of bounce around. So those are some other types of tools that we can use. And they're great. I mean, there are reviewers who use total system power. I'm not sure if he still does. I think he does, but Hardware Unboxed is one of the reviewers who uses total system power, and I'm fine with it. I mean, the way I look at it is like total system power, there's things you have to consider, but you're never really going to be wrong. So that's why it's nice. And there is something to be said for you can make an argument that, well, in the scope of the whole ecosystem, let's say the CPU is faster and the GPU is doing less work. You could argue that this is a valid number to present, but you're looking at total system. So you lose some of that granularity of precisely the CPU and what it's doing, which is what we really care about. So it just comes down to what do you care about as a tester, where if you care about the sort of holistic system-wide experience, total system power is great. And I think both are important, but there's kind of limited time. And if you're like us and you care about specifically this part that this company made that we're reviewing right now, then you gotta isolate as much as you can to get the GPU out. But there is something to be said for example, drivers behaving differently for GPUs across CPU vendors. Like AMD, Intel might behave a little differently. As you get closer to the FPS limit with a higher performing CPU, it's possible that the GPU power consumption changes pursuant to that. So there's a lot of factors to consider. There's a lot of sort of philosophy for how to approach it. And I think all that really matters is whoever's doing the reviewing has thought through it and knows their reasoning and presents their data with that reasoning in mind. So our approach, like I've said, is to just try and get the CPU. So all that said, if we want the CPU and we need 24 pin, we need to isolate out the PCIe slot power. There's not a lot of great ways to do that except an interposer, which is what this is sitting on. So we have a GPU. Do you like PCBs? Because we put PCBs on your PCBs so you can PCB while you PCB. The video card is sitting on top of an interposer, which is going into the PCIe slot on the motherboard, which is on top of an interposer, which is on top of a PCB test bench. I think I probably need to just build another one of these to make it all make sense. So what we're going to do with this, the end result of this, the data I'm going to capture overnight here and use to actually determine if my tip was accurate or not. We're going to take the slot power as well, and because that is fed in through this cable here, this is a whole level of jank, I'll explain in a second, but it's a 4-pin, like an EPS 12-volt 4-pin coming out of that slot interposer, going into an EPS 12-volt, which then goes into, do not do this at home, a PCIe. And like, don't convert PCIe and EPS between each other for your computer. The reason we've done it is, one, because I have insurance, and two, it allows us to feed the power into the PCIe of this thing, the Bench Lab. So basically we've got the PCIe slot for the video card going into that. So this is technically, it's kind of like intended to be used for an 8-pin going into your video card. There's no reason you can't use it for anything that you've converted to it. So we convert EPS 12-volt to PCIe, fed it to this, and now what I'm able to do is basically supply the slot power through an auxiliary power connector. And because we're doing that, we're able to isolate that power, just ignore it, or whatever. It may be useful for something, we'll have it if we want it. Here's what we're gonna do. The other one of these I built is just on our older style test bench, which is all like nylon parts. I'm gonna try and put this on the open bench table. My understanding is they've collaborated. So we're gonna build one of these up, and then I'll show you all kind of what it looks like. And we're really just sharing a lot of processes today. And this is experiments, I guess. I just try to we don't normally do this kind of video anymore. And so I just wanna make it clear for everyone, this is showing experiments and experimentation and sort of, let's see if we can develop any new methodologies, get any ideas from this, maybe there's shortcomings. I don't know. That's the difference with this kind of video, is because it's not scripted, it's a discovery process. And we'll discover all that for the review and let you know how it goes. But we wanted to let you all in on it just because it was, I had a lot of fun working on this. So, all right, let me show you the kit we're working with. So this is the thing I'm going to set up. These are the cables that are specifically designed for Bench Lab. Like power supplies, can't mix and match these. I'm not making a tutorial here today, so I'm not going to explain all the setup precisely. But those are the cables we're going to use. It also comes with a few other things, so we're going to need some of this stuff. Unfortunately, YouTube is filled with so much bullshit product, fully sponsored showcase videos these days. I do have to repeatedly make clear I decided to make this video because I like it and I bought it. So these are our standoffs. I think what we need to do is replace the bench table standoffs with these. There's some other stuff in here too. So these are either thermocouples or thermistors. I would need to double check. The other end, we've got just, this is going to be a slower responding sort of thermometer. This would be great for ambient temperature. You could shove one into a liquid cooler or something too for water temperature. So that's what that is. There's some more of them there. This is because the Bench Lab supports temperature sensors. And then we've got a 4-pin to 4-pin, RGB to RGB. And actually, this is pretty cool too. Let's walk back over here. I'll show you why it's cool. So because this breaks everything out, I'm going to plug you in the mouse and the keyboard into the interposer. And then the fans, we can also feed completely through the board. It's got this toggle switch. So what I set up on the other one, and I don't know methodologically if we'll go with this for everything, but I just set it to 100%, and I plugged the fans all into the interposer, into the subboard, rather than the motherboard. And then I told the motherboard BIOS to ignore the CPU fan presence. The 24-pin has 3.3 volt, 5 volt, 5 volt standby, 12 volt, of course. And so not all of these go to the CPU necessarily. And some of them it's not clear. So I called someone from an engineer at AMD. I'll just name him. I called Bill Alverson. Many of you have seen him in our videos. And I was asking about, does a CPU use, like how much 3.3 volt or 5 volt might a CPU actually use? And his answer was, well, it's kind of complicated because some board vendors will take 5 volt and then step it through a solution on the board to then get something like the AMD 1.8 volt PLL or whatever that setting is. So anyway, it's kind of complicated, which is why this is the objective is to isolate everything. These standoffs need to be removed, and I'm going to try replacing them with the ones included. There is a manual, and I read the part about the software and how everything's wired, but like most of you, I'm better than instructions that involve things like screws. And by better than, I mean I'm going to get through this and really regret not reading probably one sentence and have to undo all of it. Is that right? Yeah, I think that's looking pretty good. See? See? We don't do instructions here, all right? All right, so these are the standoffs to the board, which will sort of sync on that. I'm going to take this platform, transplant this onto the setup over there. The most important cable that we're measuring today. Why do they put such heavy back plates? See that? So this is the open bench table thing, but if we get a shot low down of that piece right there, you see it sticking up. So that was the one I screwed into the top, and no screw required. It's sort of like, it secures it, so it's pretty good. And then you can see our testing notes all over these platforms. That's to avoid sharing PCIe lanes when we don't want to. Now the fun part. Oh no, wait. That happens later. Stop getting ahead of me, all right? We need to connect all of the cables. So we're gonna do the ATX 24. I'm gonna need one 12 volt high power. So that gives us the GPU, dedicated tracking. This is part of why I wanted to show this too, because like this is probably happening for like all of our power testing going forward. We've been doing a lot of power testing already, but this is gonna just make life a lot easier to break out important numbers. So there's CPU, GPU one to convert into an EPS to feed the interposer, the slot interposer. Now it's just the cables from the power supply. One problem is this is not the right power supply, so we're gonna swap that. Something that's really important to know about tools like this is the more advanced you get, and I'm not saying that the Bench Lab is not like the most advanced thing you could do, but the better tools you get, the higher the sort of risk is of getting something wrong, because you're gonna get it you'll get it wrong with extreme confidence, which is sort of the risk. And that's something we try to be permanently aware of. There's always a chance of screwing something up, but respecting the tools you're working with is really important. I mean, it's the same as physical hand tool type stuff. I would like to use a power supply with a native 12 volt high power. I wonder if this has native 12 volt high power. Okay, I think that's everything we need. Now we connect all these. Okay, so interposer, 4-pin, extension, and slot. I have to figure out this situation. I really want this to be mounted in a way where the whole thing can be picked up and we don't need a bunch of twist ties like I have right now. Yeah, so that's what we're gonna have to sort through. Oh, it's not threaded. Cool. It's almost there. Elmor's watching this and he's like, there's a step 2 in the manual and there's a screw. Literally can't be stopped. Oh. Can you cut the part where I said can't be stopped? There we go. Vince Kingpin Lucido strikes again. Damn it. Almost perfect. So let's try it. That's fine. Yeah, that's pretty good. I could put a washer on that. You know what? We're still gonna need twist ties because this is still too wobbly. Look at this shit. Oh my God. Still need twist ties after all that. Can you just like right there? Thank you. All right, I'll see you later.
It's not sketchy at all.
Vitalii, this is a team effort. Our genius knows no bounds. Let go and walk among us. Amazing. It's the most stable video card ever. This is our soon-to-be structural 24-pin connector. Where's this shit? I forgot one. It's okay, it's only the one that actually matters if it's not actually completely seated. So this is the software. Right now we're just on Windows Desktop. There's a lot of stuff I can't show from our test environment, just custom coded stuff we make. I can show this though. So what we're looking at right now, so we have GPU power, CPU power, system power, and then I'm gonna pull like log data from this and kind of parse it on my own and use our own processing, but this gives you a live window looking at it. You can update the monitor interval, so we go to 100 milliseconds if we wanted, which is kind of wild. But so this is not quite like where you'd want it for if you're trying to measure transients or something, where you need scale down in the tens of microseconds. That's an oscilloscope is great for. Let's slow this down just for purposes of this video, though. So not quite transients for how I would use this, but it's perfect for what we want. So this is ATX 3 volt. So this is a 24-pin, 3 volt line. You can see, I mean, it's up and down a little bit. The scale here is kind of silly. So that's 2.95 to 3. Oh, there's a max and min value right there. So there you go, 0 to 10. Anyway, so the current, power, voltage, which we can read over here on a different screen. So there's reference voltage, there's all the ATX voltages, EPS voltage, all that stuff. It's all loggable. And what I'm gonna do is kind of filter through this data as it's captured in a log file, not through the interface, and use that to do my best to isolate for the CPU. So like if we look at EPS 1 power and EPS, where's 2? EPS 2 power, I mean, right now we're just on, like I said, desktop, we're not doing anything. All the other system power, except for RAM and stuff like that, is going through the Elmor board. So like even fan power is not going to show up in this area, although that would be through ATX. But anyway, EPS is combined doing like 10 watts right now. And then we could also take ATX, 12 volt. So let's find that. There's the current, there's the power. So there's like 24 watts or so. We could adjust the scale. Now PCIe 1 is the interesting one. So PCIe 1 power, this is the slot. So this is the one that's plugged into a 4-pin EPS. And you can see it's like 8 watts to 10 maybe, just kind of spitting out a display and keeping the card up. Now slot power ultimately splits. I forget if it's a 5 or a 3 in there, but it's not just 12 volt. So the spec is 66 watts, 12 volt through the slot, and then the rest comes through the other rail, or rails as it may be. And then there's our 12 volt high power right here. Just doing 8 watts right now on desktop. So pretty cool stuff. All right, so the only thing we're really missing with this, we can't separate some devices. There's just, no matter what you do, you're not going to get a perfect separation of the CV power only unless you go to another level, which is, I guess, I haven't actually done this, but I guess you could probably probe pins. You might be able to do something on the backside or the pads, something like that. So there's stuff you can do, but in terms of being able to just plug stuff in and not custom hunt down the pads or the legs on whatever you're measuring, this is pretty close. So we're not able to isolate out the network, so the NIC, if it's like a 10 gigabit NIC or whatever, we wouldn't be able to isolate for that power. It would just be in there with ATX most likely. I think it's ATX, I'm not 100% sure. And then same thing goes for all the various other controllers on the board. So all the stuff that processes I/O, all the special features a board may have. If the board itself has RGB LEDs, meaning not externally connected ones, then I don't think we'd really be able to isolate for that. And so anyway, there's limitations of the testing as always, but the objective with it is, okay, with these limitations, we're trying to narrow it down so we get rid of the big ones, like the PCIe slot power, where that could be 40, 50 watts or something, depending on the card used. And so that needs to go, because that creates noise where it's actually going to meaningfully move what it looks like the CPU is pulling if you're measuring ATX as well. So that's kind of what we're doing. There's some noise in there. There's always going to be like a fudge factor, and we just try to be transparent with what the limitations of the measurement tools are in the process. And EPS is really clean because like that goes to the CPU and that's kind of it. But it's not good enough anymore. And wall power would be an option, but it doesn't give us the sort of test resolution that we really want. So anyway, you're gonna experiment with this. It's really cool. It was fun to set up. I think we're gonna have uses for it. And now it's just gonna be the natural process of deploy it, try it out, and then iterate one review to the next and just kind of narrow it down to what we think is the best solution for this going forward. Because Arrow Lake, if the tips we've received are correct, is going to get complicated with some of the power measurement. So, but we'll see how it works out in reality, because I guess I'll know basically as soon as the camera's off. So that's it for this one. Thanks for watching. Subscribe for more. Go to store.gamersaccess.net to help us out directly with all this type of testing. We're always coming down to the wire using all the hours in the embargo to do testing. So support us on the store if you can, or you can just watch more videos. We've got more coming up, and we'll see you all next time.